Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the greatest integer function, right? And here again we have a very nice problem, and here we have to find the value of this integral from -1 to 0, and the integrand is greatest integer of x minus greatest integer of 2 times x, right? So let us call this integral as I, right? Now here we can adopt two methods to solve this integral, right? So the first one is to apply the method of inequalities, and the second one is by method of substitution, right? So earlier we have already used the method of inequalities to solve these kind of integrals, but in this lecture we'll prefer the substitution method, right? So let us start. So here let us first take this term, that is 2x as t, right? So we'll take t variable equal to 2x, right? Now differentiating both sides with respect to x, we have dt over dx is equal to 2 times 1 because the derivative of x is 1. So we have dt over 2 is equal to dx, right? Okay, now see, whenever we use the method of substitution in definite integrals, we always change the limits, right? Now see here, the limits vary from x is equal to -1 to x is equal to 0. So the lower limit is -1 and the upper limit is 0. So when x is -1, then we can substitute x is equal to -1 here. So we have t is equal to 2 times -1, so t is -2, right? And when x is equal to 0, the corresponding value of t is 2 times 0, that is t is equal to 0, right? So when x goes from -1 to 0, our new variable t, it goes from -2 to 0, right? So now let us rewrite this integral I in terms of the new variable t, right? So now we have the limits from -2 to 0, and we have greatest integer of x. Here for x we can write t over 2, right? So from here x is t over 2. So here we have t over 2, and here we have minus greatest integer of 2x. So 2x can be replaced by simply t, and here for dx we have dt over 2, right? So now we have this integral, right? Okay, now see, whenever we come across with the greatest integer function, our prime aim is to search for integers, right? Now see, here the limits of integration are from -2 to 0, right? And we know that between -2 and 0 we have the integer -1, right? So here what we will do, we'll split this integral as a sum of two integrals, right? So between -2 and 0 we have this integer -1. So what we will do, we'll first write the integral -2 to -1, and we have greatest integer of t over 2 minus greatest integer of t, and here we have dt over 2, right? And the second integral is from -1 to 0, right? So here we have -1 and here we have 0, and we have greatest integer of t over 2 minus greatest integer of t, and here we have dt over 2, right? Now our aim is to get the values of these two integrals. So now see here inside this greatest integer function symbol, we have another greatest integer function, that is greatest integer of t, right? So what we will do here, the value of t varies from -2 to -1, right? So in the first integral, t varies from -2 to -1, and from the definition of greatest integer function, we know that when t lies between -2 and -1, then the greatest integer of t is -2, right? And similarly, in the second integral, the value of t goes from -1 to 0. So t lies between -1 and 0. So the greatest integer of t when t lies between -1 and 0 should be equal to -1, right? So now what we can do, we can replace this greatest integer of t by -2 in the first integral, and in the second integral the greatest integer of t may be replaced by this value -1. So now these two integrals can be written as -2 to -1, and here we have greatest integer of t by 2. And when we take greatest integer of t as -2, so this negative sign and this negative sign becomes positive. So here we have +2, and the second integral is now equal to -1 to 0, and here we have greatest integer of 2, and this negative becomes positive. So here we have +1, and here we have dt over 2, right? So now these two integrals are simplified to these two integrals, right? So now let us again apply some inequalities to simplify these two integrals further. So now let us first take this one, right? Now see here we have greatest integer of t over 2 plus 2, right? And here the value of t goes from -2 to -1, right? So we'll take these two integrals one by one. So let us first take this one. So t lies between -2 and -1, right? And now see here we need to get t over 2 plus 2, right, from this inequality. So what we will get, what we will do, we'll divide both sides by 2, right? Now see what we have done here, the value of t goes from -2 to -1, -2 to -1, right? Now let us divide both sides by 2. So here we have -1, here we have t over 2, and here we have minus half, right? Now see we want to get t over 2 plus 2. So let us add 2 throughout this inequality. So we get -1 plus 2. Here we have t over 2 plus 2, and here we have minus half plus 2, right? So this is 2 minus 1 is 1, and here we have t over 2 plus 2, and here we have 2 to the 4, 4 minus 1 is 3 over 2, which is 1.5, right? So what we have got here from this inequality, that is t greater than -2 less than -1, we have obtained this one. So this inequality suggests that t over 2 plus 2, it lies between 1 and 1.5, right? Now see here we have 1 and here we have 2, and here between 1 and 2 we have 1.5, right? So this quantity t over 2 plus 2, it lies between 1 and 1.5, right? So the greatest integer of t over 2 plus 2 should be equal to 1, right? So this is an important point here. That's why we have started with this inequality, and we have done all these operations to get this inequality, right? So the greatest integer of t by 2 plus 2 is equal to 1, right? So here we'll replace now this quantity by 1, right? Okay, now let us take this one. Now see, here we have t greater than -1 and less than 0, and here we wish to get t over 2 plus 1. So what we will do, we'll divide throughout by 2, right? So we have minus half, then we have t over 2, and here we have 0, because 0 divided by 2 is equal to 0. So now here we have t over 2 plus 1. So let us add 1 throughout this inequality. So we have minus half plus 1. Here we have t over 2 plus 1. Here we have 0 plus 1. So minus half plus 1 is half. And here we have t over 2 plus 1. And here we have 1. So t over 2 plus 1, it lies between half and 1, right? So if we have this number line, then here we have 0 and here we have 1, and t over 2 plus 1, it lies between half, this is half, and 1, right? So the greatest integer of uh, t over 2 plus 1 should be equal to 0, right? So when t over 2 plus 1 lies between half and 1, then the greatest integer of t over 2 plus 1 is 0, right? So here we have 0, right? So we can now see that this integral disappears, right? The value of this integral becomes 0. So now we left with only this integral. So we have minus 2 to minus 1, and the greatest integer of t over 2 plus 2 is 1. So here we have 1 dt over 2, right? And the value of this integral is 0, because greatest integer of t over 2 plus 1 is equal to 0. So now we have this integral. So we have I is equal to, we can take half outside, and the integral of dt is simply t. So we have t, and the limits are from -2 to -1, right? So now we can substitute the limits, and we can take the difference. So we have -1, then we have -2. So this is half, -1 plus 2. So this is half times 1, that is equal to half, right? So the value of this integral is half, that is equal to 0.5, right? So viewers, this is how we can solve these type of definite integrals involving the greatest integer function.